Hi everyone, welcome back. In this lecture, let's create a Maven profile example to demonstrate how to load different database properties based on the active environment. In simple words, we'll switch between development and production using Maven profiles. Let's begin. Let's go our Maven project in IntelliJ. Inside our project, let's go to the folder named Resources, which is under src, then main. Now inside this resources folder, we create a new file and give it the name db.properties. Alright, now let's open the file and define some placeholder variables. We are going to use Maven style placeholders, which means we'll wrap our variable names using $sign and curly braces. So let's quickly add the database configuration inside the db.properties file. Type db.driver, class name equals $sign. Within curly braces, db.driver's class name. This property is for database driver. Then go to the next line, db.url equals $sign within curly braces db.url. Next line, db.username equals followed by $sign within curly braces db.username. And finally, db.password equals $sign within curly braces db.password. Great. So this file now contains 4 key value pairs, but they are not actual values yet. They are placeholders. These placeholders will be filled automatically based on the active Maven profile when we build the project. But for this to work, we need to tell Maven to actually enable filtering, which means replace those placeholders with actual values. So let's move to the next step, enabling resource filtering. Open your pom.xml file. Scroll down to the build section. Now inside the build section, we need to define a resources block. This is where we tell Maven to process all resource files and specifically apply filtering for our property file. Inside build, add a new tag, type resources. Then within it, add resource tag. This tag will define the location of our resource files. Inside resource tag, add a tag called directory and type src/main/resources. This tells Maven where to look for your resources. Now the important part, inside the same resource block, add a new tag, filtering, and set the value to true. This tells Maven, hey, go ahead and replace those placeholder values with actual properties based on the active profile. So that's it. By adding filtering as true, Maven will scan your db.properties file, find all placeholders like $open brace, db.url close brace, and then it will look for matching values in the currently active profile and replace them. This allows you to maintain one common properties file and inject different values for development, production, or test environments based on which Maven profile is activated. Let's now set up 2 profiles in Maven, one for development and one for production. Each profile will provide a different set of values for database configuration. In pom.xml file, before closing project tag, add the profiles section. Now within a profiles section, we will define 2 profiles, one for development and one for production. Let's start with the dev profile. Inside the profiles section, we add a new profile. Give this profile an ID, set it as dev. Now we add the activation block. Inside activation, we first type active by default and set it to true. This tells Maven if no profile is explicitly selected, go with the dev profile. We also want Maven to activate this profile when a system property named env is set to the value dev. So inside the activation block, add a property section with name as env and value as dev. Now inside this dev profile, add a block for properties. This is where we inject environmental specific values. Let's define 4 properties. First, type db.driver class name and set the value to com.mysql.jdbc.driver. Next, define db.url and give it the development database address. Set the value to jdbc://localhost:3306/dev-db. Then set the username using db.username. Finally, define db.password and set the value to password. That's it for the dev profile. Now let's define the production profile just below it. Again, start a new profile block. Give the ID as prod. This one is not active by default. It will be activated only if the system property named env is set to prod. So we again create an activation block and inside it define the property name as env and value as prod. Inside the properties section of this prod profile, we set all 4 values again, but this time with production specific information. Set db.driver class name to the same MySQL driver. Then for db.url, set it to jdbc://live01:3306/prod-db. Set the username again to Java Guides and the password to password. And now both profiles are done. Next, in order to test this, we'll write a Java class that will load the db.properties file at runtime and print the database configuration values to the console. Let's open the app class. So here I quickly write the code and explain the same. At the top of the file, we imported 3 Java utility classes. First import java.io.ioException, then java.io.inputStream, and finally import java.util.properties. Inside app class we'll add 2 methods. First is the main method. This is where the execution starts. Inside the main method, we created an object of the app class. Next, we load the properties file, call the method loadPropertiesFile, and pass the file name db.properties. The method returns a properties object, so store the result in a variable called prop. Now to print the loaded values, we loop through all the entries in the properties object. Use the for each method and for each key and value, print them using system.out.println. Alright, now let's create the actual method that loads the properties file. Below the main method, we define a new method, use public properties loadPropertiesFile, and pass a parameter named filePath of type string. Inside the method, we created a new properties object. Now comes the important part. We need to load the file using the class loader. We use a try with resources block to safely open the input stream. Inside the try block, call prop.load and pass the resource as stream. This will load all key value pairs from the properties file. If an exception occurs, catch it using catch open parenthesis, IOException, close parenthesis, and inside the block print an error message. We now have a complete Java class that loads the db.properties file dynamically based on which Maven profile was activated, dev or prod. Now, let's test how Maven profiles automatically inject different environment values even if we run the app class directly from the IDE. Open your terminal or integrated terminal in IntelliJ and follow along. First, we clean and build the project using the dev profile. Type the following command: Maven clean package -P space dev. Let Maven complete the build. Since we are using profile ID dev, Maven will use development database configuration. If you go the pom.xml file and go to the dev profile, here you can see the driver class name, URL, dev-db database, username and password. When we run the app class, we should get these details in the console. Go to your app class, right click on the main method and click run. You can see the output, development database configuration details printed. You can confirm with database name dev-db. Perfect. It means the db.properties file was filtered and replaced correctly based on db profile. You can also confirm this from target folder. Go to target folder, then classes folder, search for db.properties file and open it. You can see the placeholders replaced with actual values from db profile. Let's switch profiles. Let's see for production environment. Go to the terminal again and run this command: Maven clean package -P space prod. Let Maven complete the build. Since we are using profile ID prod, Maven will use production database configuration. If you go the pom.xml file and go to the prod profile, here you can see the driver class name, URL, prod AD, DB database, username and password. When we run the app class, we should get these details in the console. Go to your app class, right click on the main method and click run. You can see the output. Production database configuration details printed. You can confirm with database name prod-db. Perfect. It means the db.properties file was filtered and replaced correctly based on prod profile. You can also confirm this from target folder. Go to target folder, then classes folder, search for db.properties file and open it. You can see the placeholders replaced with actual values from prod profile. Now let's test what happens when we don't specify any profile in the command. Go to the terminal again and type the command mvn clean package. Because we marked the dev profile as active by default, Maven will fall back to that profile when no -p flag is used. Once the build is complete, again run the app class directly. You should again see the development values printed to the console. Perfect. This confirms that even when no profile is explicitly selected, Maven knows to use the default one defined in your pom.xml. Let's quickly summarize what we've learned. We created a Maven properties file with placeholder variables. Then we enabled filtering in the pom.xml file to allow Maven to replace those variables based on the active profile. Next, we defined two Maven profiles, one for development and one for production, each with its own values for the database connection. Finally, we packaged and ran app class with different profiles and saw how the property values changed accordingly. This technique is especially useful when you want to keep your build's environment agnostic. You write the code once, and Maven handles switching the configuration for you. That's the power of Maven profiles. Thanks for watching and see you in the next one.